Hello everyone, welcome back to the channel. Today is another day where I'm continuing to work on a project that I have been building for over many months. I've faced a number of challenges, but it has also come with a lot of success, learning many things, iterating into, and several concepts have been covered. I have looked at so many things concerning DevOps, concerning Docker, concerning the cloud with AWS. Now we're into Kubernetes. We have covered the front end, the back end, so many things. Okay. And if you looked at this project very, very closely, trust me, you can learn 90% of the concepts, even 99% of concepts that you need to build a usable application by users. Things like Kubernetes can be an overkill depending on the type of situation you're in, or organization or application you're building, and depending on the time of not the time, but the size of the team that you have. But either way, you can still benefit from it, and learning from it can give you good rewards, okay, in terms of learning how certain organizations deploy the applications in production, and you can get a really, really powerful job when you understand DevOps tools using Kubernetes, Terraform, AWS, Linux, GitHub Actions, and so much more. So after a while of building so many features, I've decided to concentrate on the Kubernetes side of things, or DevOps side of things, and I'm trying to work towards wrapping up that and maybe doing other cooler stuff, okay, like building an AI agent. So in the past 3 or 4 live streams, I discussed how we can move towards a stable and ready deployment using Helm. So Helm is a packaging tool for Kubernetes and will help us deploy into Kubernetes in a very predictable way, in a deterministic way, and it will help us really avoid having so many templates for all our environments, but give us YAML files that are reproducible, not reproducible, but reusable is the right word. Sorry. You must be laughing at me and wondering how I'm almost biting my tongue speaking English. Anyway, but that's it. So yeah, we have gone through a number of things, and if anything is new to you, please check the past 4 or 5 videos. Everything will make sense. So I just need to confirm from my screen that everything is okay before I continue this live stream. Okay, I know many of you watch after the stream, which is quite okay, but sometimes I just prefer having live interaction with people on the internet. All right, let's continue with this. I'll just keep the screens close by. Now, I made a few changes to some of the templates and some of the values. I'll start with the values.yaml, and of course, I will show you how to work with them, how you can render them, and how they'll be easily deployed, okay, which is very simple. If you can't see my screen, just let me know. I'll try to expand this so that it's visible, and maybe collapse this and drag the terminal down. Now, look at this, okay? We know that the values.yaml contains the default configuration, and this default configuration is loaded automatically for us. Okay, it is loaded automatically for us by Helm and is injected into our templates. It could be a template for a deployment, a template for a service, a template for a config map, a template for a secret, a template for a job. Okay, anything could work. Okay, but just know that this is the default file. Okay, that is loaded automatically, and in it I made some changes, so I'll concentrate on those changes. In the API section here, there is rolling update, okay, HPA and PBD. I'm going to explain what they add to this project. So let's start with rolling update. Okay, so every time we make changes to the API or to the worker, okay, or to our image, and we want to deploy a new version, okay, we need to update. Okay, but as we update, some pods can be kept active while other pods are being destroyed. That process of applying a new change is called a rolling update. And this setting rolling update dot max unavailable simply says that we want at most one pod to be unavailable during this time of making the changes while updating. Okay, we want at maximum only one pod to be unavailable. Okay, this can be changed. In fact, in other values that like values prod and values change, not values changing, but values staging. What's happening to me today? Since my mind is somewhere, instead of saying values staging, I said values changing. So in values staging and values prod, these two values are gonna change, and you're going to see. So max unavailable, okay, is 1, meaning we need at most only one pod, okay, to be unavailable. Then max surge means that we can create at most one extra pod. Okay, and I'm going to explain to you how all this comes about. So for resources, for now it's empty. Okay, but you're going to see that in prod we fill up the resources, and resources is simply where you specify the requests, okay, and the limits. Okay, the resources required for requests and the limits, or the maximum you can go beyond, or the minimum that you need to have for each pod. Now this way you define resources like CPU and memory, okay, how much each pod should have at the bare minimum, not each pod, but how much each node should have in order for a pod to run on it. Okay, and you're going to see that. So I'll repeat, max unavailable simply means that you shall have one unavailable, okay, pod at any point. And max surge simply means we shall have at most one extra node being created. And you're going to understand this when I go to other files. Then we have HPA. HPA stands for horizontal pod autoscaler. Okay, by default it's disabled, and we know this setting, but then I added others like min replicas, max replicas, okay, and we have target CPU utilization percentage. So min replicas means you should have a bare minimum of 2 replicas, okay. Then the maximum should be 5. So when we are scaling up, the horizontal pod autoscaler can scale up to 5 and can scale down up to 2, okay. Yeah. Then the target CPU utilization percentage is 70%, meaning that this is going to be the target value, okay, that the HPA can use when it wants to scale. So when we hit 70% consistently or above, then we can scale. Okay, we can scale up to 3 pods or 3 pods or 4 pods or 5 pods. Okay, then when it hits again below, we can go back to either 3 pods or 2 pods, and we shall see all this. Then PBD is enabled by default as false. Okay, saying enabled by default is confusing. Then again, you say enabled by default as false. That's misleading. I meant to say the value enabled is false. So it is disabled by default. Then min available is 1. So PBD in full means pod disruption budget. Okay. It is simply a configuration which gives us the number of pods which should be available when we have voluntary disruptions in our cluster. So when you have a voluntary disruption like pod draining, so pod draining is an example of a voluntary disruption. When you have pod draining, we should have at least one pod remaining, okay? But remember, this does not prevent things like maybe cluster crashes, node crashes, maybe network failures, application failure. It does not prevent that, okay? But when there's a voluntary disruption, we shall have at least one pod being left available. Okay, so if you have any question concerning this, please go ahead and let me know. Okay, so I will move on to the next file, okay? And each of them have these, so I'll use that as a chance to even explain them deeply. So I'll leave this open and go to values staging, okay? If you go to value staging, everything else is the same, okay? We have secrets, okay? I'll not explain this part because I touched on it in the past and I don't want to waste time for those who have been here, okay? Secrets is false, we have config, worker.replicas is 1, okay? So I'll start from the top. So just to show this, okay? So for value staging, you see that we image, we have a repository, okay? And the repository is saying, replace me. Do you see that? And you curious, it says replace me dot dkr, okay, blah blah blah, okay, pointing to something on Amazon. Then arrow bound. Then here says tag replace me, okay. But if you go to values.yaml, it says repository arrow backend tag local policy if not present. Okay, what does this mean? It is simply a value that we're going to replace when we get to another stage. We are going to use Terraform, okay, to give us a repository on AWS ECR, okay. So AWS ECR is where we're going to store our images, okay. And that repository will be created once and it will be a stable value that we shall fill in right here, okay. That's why you're seeing this replace me values. And if it changes, we won't need to come and maybe manually change this, okay? There's a way you can inject it into your Helm template and you will see, okay? Then for the tag will also keep changing. Every time we commit, we want this tag to change. The tag will be the commit SHA, okay? Which is simply a random string or a random hash that will be given to us by the CI on GitHub Actions. Then when you come to API here, you see we have one replica. Then for the rolling updates, we have the max unavailable being 0, okay? And this will help us to achieve our desired state. That at any point, we don't want any pod to be unavailable. We want our desired state, okay, to always be met, okay? And yeah, that's what we want to have. If you go to the default here, you'll see that we have the HPA, okay, min replicas 2, okay, and max replicas 5, okay. So we shall have a minimum of 2 arrays, okay. But remember, here by default is enabled, it is disabled. That means that also for staging, we shall not have auto scaling. Why don't we need auto scaling for staging? Because of costs, okay. Because it's a staging environment, I just want to focus on testing, okay? We want to simply test. Staging is an environment for the internal tool. You don't expect to have a lot of traffic. And because of that, you shouldn't have things like scaling and scaling up, scaling down. That's unnecessary, okay? You'll have little traffic. So that is disabled. But you're going to see in the production values file that we're going to have auto scaling, okay? Scaling up and scaling down. So for rolling updates, we can have max unavailable to 0, okay, and a max surge to 1, meaning one extra node, not extra node, but extra pod, okay. With Kubernetes, it's tricky. You have to be careful when you say node or pod. If I say extra node and extra pod, those are two different things. I can easily mislead you. So sorry, I meant extra pod, not extra node. So max surge gives you an extra pod. Then finally, for the resources, okay. So resources.request, for the requests, okay, we have CPU and memory. This simply means that the scheduler, okay, the Kubernetes scheduler should check for a node which has a quota of CPU available and a memory of 256 maybe bytes before creating a pod, okay. So these are think of them as the minimum requirements required for a node in order to create a pod, okay. So a node should have these at a minimum before a pod is created, as simple as that. Then the limits, we have a CPU of 500, okay. So this is the maximum, okay, you can have for CPU. Once the CPU usage reaches 500, then at that moment, that is when we can now start CPU throttling, okay. But for a memory of 512, then in that case, things change. We can also maybe have an error, okay? There's an error called an out of memory error, okay? That Kubernetes can throw when you exceed that limit, okay? It may throw that error. So think of this first value that this is simply the minimum requirements needed, okay, for the scheduler to check on a node. Does a node have these minimum requirements? If it has these requirements, then we can create a pod, okay? Then the limits are, think of it as the ceiling where pod consumption should not exceed. If the CPU exceeds this value, okay, then we can throttle. If the memory goes way beyond this value, then we can terminate it, okay, or fail that pod. These others are the same. I'll not go through them because you have discussed them in the past. All right, now I'll go to values prod. Yeah, values prod is similar, okay? So repository, this will be given to us from Terraform and we shall inject it here. This tag will come from the git commit SHA and you'll see it soon. API, the replicas. So for production, we shall have 2 replicas in the beginning. Okay. For rolling updates, we shall have max unavailable 0, which means our desired state of 2 will always be kept. Okay, which is nice. So max surge is 1. Okay, so which simply means that when we want an update, okay, when we want to update, Kubernetes can create an extra pod, okay, having the new updates. Okay, so at some point we shall have 3 pods. Why 3? The 2 replicas which were existing, and then a new pod. That new pod will have the update. Then one of the old pods, okay, is killed. Okay, and so we now have 1 old pod and 1 new pod. That gives us 2 pods. Then again, Kubernetes can create 1 extra pod, okay, to have the new update. So that gives us again 3 pods. After that, an old pod, okay, the only old pod remaining is then deleted. So in the end, we have 2 new pods which have the latest updates. You get, that's the best practice of handling this. And that's an easy way of giving us availability, okay? Having 2 replicas and having a max surge of 1 gives us maximum availability for our setup. Then for the resources, we have the same requests, okay? So CPU, we have a quarter of a CPU. Actually, I think I said something wrong on staging, okay? For staging, we have, if you look at staging, we have an eighth, okay, of CPU. So forgive me for that. So for staging, it is an eighth, okay? And for prod, we have a quarter, okay, of CPU. As simple as that. Then when we come to the limits, we have one whole core, okay, and one GI, okay? Because we're in production, we need a little bit more resources. That's why I stepped this up a little bit. And if you look at this, it simply means the same thing, okay? For request.cpu and request.memory, when the scheduler wants to create a pod, it simply first checks the node, okay? Checks the node to see that this CPU and memory requirements are met before creating it. Then for limits, once we reach this limit, okay, and maybe a pod wants to use more than one core, then we can throttle. As simple as that. All right. Now in production, we have HPA enabled and PBD. Okay, so you see HPA enabled is true, and we have PBD enabled is also true. So for the min replicas, we have two. So you shall always have a minimum of replicas when scaling down. Then the maximum replicas will be 5. Okay, and the target CPU utilization percentage will be 70%. So this will be the target that the horizontal pod autoscaler will look at, okay, to determine whether we need to scale up. Then for the pod disruption budget, okay, which means the setting that tells us the minimum number of pods that we need in case of voluntary disruptions like pod draining, not pod draining, but node draining, okay? So in case a node wants to be drained, then we should have at least one existing, okay? Remember that this does not prevent hardware crashes, network failures, application failure, okay? It only helps you when there is a voluntary disruption. The rest down here are the same that I've dealt with in the past videos, so I'll not open them, okay? Just to save time. So if the rest, like worker config secrets, is new to you, please check out the past videos. Okay, so we're getting close, okay? We're getting very, very close. So we go now to templates, okay? In templates, then we have the API PBD and the API HPA, okay? They are very short. So this file, okay, will only be rendered, okay, if, let me minimize this, if HPA is enabled. So it says if values.api.hpa.enabled. So values comes from the values object, okay? And that will come, for example, for staging, okay? HPA will be disabled, okay? Why? It comes from here. So this values file, okay, will be overridden by staging in the staging environment. Values file will be overridden by the values prod in production. So by default, HPA is disabled and PBD is also disabled for staging, okay, and development. But in production, okay, it is enabled. You see, HPA enabled, true, PBD enabled, true. That's the difference. So when we go to here, okay, this will only work in production. Okay, we want horizontal pod autoscaler in production. So the first line gives us the autoscaling version 2 as the version, okay, of this resource that we're going to create. The resource that we want to create is a horizontal pod autoscaler. Okay, so this is the other type of resource we are looking at in Kubernetes. I think we've discussed a number of resources. We have a deployment, this is resource 1. We have horizontal pod autoscaler. We have a service 3, a config map 4, a job 5, a secret 6. What else? What else? I think about 6 so far. Okay, and who knows, we may actually get to use way more. So metadata, we have the name of it. So it will be called Aero Backend, which will be our release name, then minus API. When I get into this, we have the scale target ref. Okay, so in the scale target ref, simply tells us what resource we are going to scale, okay? And says we are scaling a resource that belongs to the apps v1 API version, and it's of a type deployment. It's a deployment, okay? And the name of this deployment is this, okay? So I'm going to render this for you and you will see it. Then the minimum number of replicas will come from our values, okay? And the maximum replicas will also come from our values. And I'm going to render this for you and you'll see it working. When I go to metrics, in metrics, you see, we now have the type. We have only, one resource. Not one resource, but one metric, okay? Of type resource, okay? And what resource are we looking at? We're looking at the CPU, okay? And what's that metric? What's the target metric we're looking at? It is CPU utilization, okay? And that value, okay, which is called the average utilization, will be got from the values.api.hpa.target CPU utilization percentage. Okay, as simple as that. Then at the end, we have an end of the if statement. As simple as that. So when you look at these manifests again and again, it becomes quite easy to study them. Okay, it becomes quite easy to study them. I see nothing really challenging with them. So I'll clean up this, not clean up, but close it and open this other one. So PBD is also similar. So like you see, it says if values.api.pbd enabled. So this will be enabled only in production, like I've showed you in the values files, okay? So depending on the environment. So by default, it is disabled. In staging, it will be disabled. In development, it will be disabled. In production, we shall override that value to be true. Okay, here's what you see here on line 24, pbd.enabled true. So when it is true, that's when this template will be rendered. Okay, and now we have a new resource type called PodDisruptionBudget. Okay, and that is the 7th resource type we are learning about, and it belongs to the policy v1 API version. The metadata simply has a name like arrays, which will be named after our release name, then dash API. Okay, then we go to the spec. The spec, we shall pick the minimum available, okay, which comes from the values.api.pbd.min available. Very simple, okay. In fact, when you understand the values.yaml and you come to these templates, things are much easier. Then the selector, again, remember a selector is simply a search and find tool, okay? Just like I explained to you in the deployment and survey. So the selector.match labels will be named, okay, after the release name, then dash API. So if the release name is error backend, it will be error backend dash API. As simple as that. So that's how our pod disruption budget template will be created, and that's what it will do. Okay. All right. So it will help us find pods that match this label. Okay. All right. So I'll close that and go to API deployment. Okay. So in API deployment, also there are a number of changes that I added. Okay. And what I added was only, I think, 2 things. The first one is right here. Okay. In the spec.strategy. Okay. So yeah, the strategy will be of type rolling update. Okay. We want to set up how updates will be made for our pods. Remember, a deployment manages pods. Okay, it starts the pods. Okay, it creates more pods, reduces the number of pods. If a pod fails, then it is replaced. Okay, that's a process called auto healing. So just know that deployments help us to manage our pods. Okay, so we can apply the rolling updates to also the deployment to help us manage the pods. And that happens under the strategy specification. And you see that it is of type rolling update. Okay. Then you say rolling update, okay, needs a number of things. What is the maximum number of unavailable pods that you are acceptable? Okay. that value will come from our values, like I explained a few minutes ago. Then the max surge, okay? What is the maximum number of extra pods we can create? Okay, the value will come from the values. Okay, as simple as that. So max unavailable will help us keep our desired state. For example, if you put it to 0, it will help us with that. And max surge will help us to create extra pods so that we have an extra pod being created as a new pod with the update, while the old pods are being used to serve the client requests. Okay, then after that we can swap one old pod with a new pod and continue repeating until we have our desired state. Then I think one more thing I added was down here. Just a moment, let me go down. I think in the template at the bottom. Okay, so here I was saying with values.api resources, think of this as an extension of this template using the values.api.resources. Okay, simply creating another resources block, okay, from the values.api.resources and converting that map, okay, to a YAML file, okay, and indenting, okay, printing every value, okay, on a new line, but giving an indent of 12 spaces. As simple as that. Okay, I'll repeat. With values.api.resources simply means that we are going to pick values from the resources in the values that we have, okay, and create a new block called resources, extend it by mapping all those values to YAML, okay, and then each of those values will be on a new line, but indented by 12 spaces. Then, of course, end marks the end of it. All right, so now we can test out these commands, okay? I'll pull up my terminal. So if anything is not clear, please let me know. So in the next video, we're going to go to infrastructure now, where we're going to actually deploy the things. I'm looking for my notes, okay? But I don't cram these things. The goal is to understand. If you can understand them, then you'll be good enough. And that's always my goal. Understand the concepts at a deeper level and then simply apply them, okay, in any project. That's the goal. Once you understand these things, please go and enjoy using AI to generate for you these manifests. And of course, when AI generates for you, you'll be able to guide the AI to the direct or to the correct direction, okay, to what you want to achieve, okay. And whatever it generates, you're able to know that this is what I want, this is what I want, this is wrong, this is better. Okay, so what's a good first step? Sometimes you're working in a multi-cluster environment, okay, so you may want to first confirm your context, okay. So I'll say kubectl config. Is that config? Yeah. Current. Can I spell current? Then context and hit enter. So you see, we're in the correct context. Okay. Then now we can we can use Helm. Okay. I was going to say we can Helm or use Helm to lint. Okay. So to lint, it's very simple. We shall start by linting the default values. Okay. By simply saying Helm lint. Okay. Then specify the location of the Helm chart and hit enter. So you see, everything is okay. So by default, like I told you, Helm will load the values.yaml. After that, we can now lint the development. Clear this. Come on, what am I doing today? So to render or to I try to do this, but it ends up opening this other. This is crazy. Are you seeing that? It's like the keyboard shortcuts have been tampered with. Okay, I've got it. All right, let's now continue. Time to lint the development. values, okay, or the development templates. So I'll say Helm, okay, lint, specify the location of the Helm chart, like that, backend. Then this time for development, we need to specify the actual file, which will be Helm, okay, backend values dev.yaml, okay. So you see, everything is okay. Then I can do the same for staging. So for staging, I'll remove this and say values staging.yaml, okay. You see, it's also okay. Then I can do the same for values prod.yaml, okay. That is also okay. Now we are done linting. We can now go to rendering, okay. Let us try rendering the development API template. So I'll say Helm, okay, template, okay. Again, template is the command that helps us to render our templates into Kubernetes manifest or YAML files without deploying. So I'll say Helm template, the release name will be arrow backend. The Helm chart is in Helm backend. Then we say -f would be the location of the values. And remember, this is for development. So I'll say Helm backend values dash dev.yaml. Okay. Then I'll say show only. Come on, show only with one dash like that. Only the templates. Okay. /API development dot YAML. Okay. And hit enter. Says could not find API templates API development.yaml. Okay, so you can simply specify, check here and see what did I do wrong. Show only, is it the spelling of templates? So templates looks correct. The API, okay, dash, okay, it's my problem. Why did I call it development? It is deployment. Okay, deployment, like that. Okay, API deployment. Okay, now we have success. So if I go through it and go from the top, you'll see that we have the name has been rendered. Okay, if you look at the rolling update, max unavailable is 1, the max surge is 1, the selection match labels is error backend API, the template metadata labels is error backend API. Okay, the image has been rendered, image pull policy, everything. Look at the env from, okay, has been rendered also. Nice. So let's now render the next one, which will be templates API. This will be now API what? I need to first of all change the values. Okay, let's go to staging. So it should be staging minus show dash only templates / what is it called? Okay, I think everything else will be the same, right? Yeah, everything else will be the same. API deployment.yaml. I shouldn't have changed this one. So if I go up, you see for staging, okay, I see now we have in the containers, you see the image having a replace me. You get, it has a replace me now. If we continue, okay, yeah, everything has been rendered properly. So this is how you can check the rendering. Everything is okay. If you look at the name API is okay. The rolling update is okay. The selector is okay. Label is okay. Image is okay. Okay, but of course we're going to replace that soon correctly. If you look at down, we have now resources being added, which is nice. So I'll remove this, then just render for production. So for production, I'll simply change this to values prod.yaml. Hit enter. Okay. So you see we have the correct resources that we need for production. Okay. The CPU is 1 cycle, memory is 1G, the request is a quarter, memory is 512. If you go up here, you see the secret ref is backend secrets. Okay. Config map ref has been also rendered to error backend config. The image is right there. Image pool policy has been rendered. This label has been rendered. This label has been rendered. Okay, the rolling updates have been rendered. Okay, the name of this resource has also been rendered. And that's what we want. Okay, now we can also render the HPA. Okay, the HPA. So to edit, I'll simply edit this command. Okay, and say Helm. Here, the template will be API API H. What is it? What did we call it? Let me see the name. API HPA. Yeah, HPA. And then yeah, values prod will be okay. Debug flag to render out invalid YAML. Oh, so we have at least we now got invalid YAML for the first time. But when we are linted, it was okay. Okay. But yeah, that is something I'll fix later. I can actually do Helm lint. Okay. Helm backend -f Helm backend values. Okay, now we have an issue. Okay, unexpected end of file. Okay, so are you seeing that? My sickhead added this without knowing. Okay, I've undone it. I was starting to wonder what happened when everything was passing earlier. So if I close this and do this again, yeah, so the horizontal pod scaler is okay. See, the name has been, by the way, these names can be the same, okay, but there will not be a conflict because they are different resources. Yeah, the first time I was learning this, I wondered. So if you're wondering about that, don't worry. So you see the scale target ref. Okay, all this has been rendered also. The min replicas and max replicas have been rendered properly. The metrics have been rendered properly. Okay, up to right down here. Okay, that's nice. Let's now do the pod disruption budget. I'll change this to API PDB. Okay, so I'm not typing out the full commands anymore because I've done this for the past 4 or 5 videos. In the case that you don't understand, you can ask me a question. So for the source, mean for the API version, okay, kind, okay. Metadata, we see the name has been rendered correctly, and everything else, including the selector label, has been rendered well. Okay, so I'm checking my notes to see if there's anything else we need to do. Yeah, I think that's all. We're now ready to create the EKS source and move. Okay, and move on. So you can even check all pods. Okay, all pod resources and see that things are okay by saying Helm template. Okay, release name can be error backend, but they don't cram that it should be error backend. It can be anything you desire. That's a good name and makes sense for you or your team. Arrow backend. The chat is in Helm /backend -f Helm backend values prod.yaml. Okay, then I can pipe everything into the grep command, and I look for anything that starts with that caret starts with kind. Okay, hit enter. So you see, we have kind pod disruption budget, we have kind config map, we have kind service deployment, horizontal pod autoscaler, and job. So about 1, 2, 3, 4, 5, 6, 6 kinds, okay, of Kubernetes resources, which is nice. Okay. So yeah, I just use the grep. Okay. So grep is simply a Linux tool or a shell tool that you can use to do a find and search, okay, of strings. So I simply said render everything, okay? This first command that you're familiar with rendered the Kubernetes manifest, and that will be simply a string or a YAML, okay? Then I passed it using this pipe command to the grep command. I told grep find everything in our input, okay, that starts with kind. So this caret means start, okay, start with kind. And that's what we got. We can even do any kind of regular expression search, okay, until work. All right. We can also validate against Kubernetes without deploying, okay, by doing the same command helm template, okay, arrow backend, okay. Let's use something else, okay. I'll say prod check, arrow prod check, okay, to change the name, arrow prod check, and the chat will be in the same location, okay. The values file will be helm backend values prod.yaml, okay. And this time I'm going to pipe that, okay, to kubectl. I hope I remember how to do this. Kubectl. Then you can say kubectl apply, okay, apply this, okay. So all this, remember the first part which I've highlighted is going to help us to generate Kubernetes manifests, okay. And we want to pass them to kubectl apply, because kubectl apply will try to maybe deploy, but you don't want to deploy, okay. We're going to avoid the deployment by saying dry run, okay. So dry run is like being able to deploy to Kubernetes, okay, without, okay, like being able to test your configuration, okay, in Kubernetes without actually deploying it. So I'll say apply minus namespace to namespace. The namespace was arrow dev, excuse me, and then we say minus, I think these two minuses, dry run equals to server, okay, then minus f dash, okay, then we hit enter, okay. So you see we get dry run, css config map, arrow project config created, okay, for the service, okay, created for the deployment of the API, created for the deployment of the worker, also created for the, what is called the autoscaler, has also been created, okay. Isn't that nice? So I think you see why that works, okay, and how it is good. So this is the time when you have a question, you can ask me. Yeah, so even at the end for the job, it was created. So everything is perfect and okay. Okay. By the way, if you're asking what this F means, this F simply means use a file input. Okay. Use a file input, or yeah, use a file input as a standard input. And that file input will come from this Helm. Okay. Yeah. What else? Yeah. And of course, the minus means use standard input, okay, instead of an actual file. Yeah. So If you know Linux, things like standard input, standard output, standard error should be common to you. So this is nice. In the next stream, I'm going to dive into the actual infrastructure, okay, and create it. So I think we are ready to now step up. Thank you for watching with me and building with me. I'll see you in the next